Welcome to Object Methods lecture. According to the poll yesterday, let's see. Can you guys hear me now? Nice. So, I'm gonna go over some of the problems from yesterday and review some methods on objects and how to access certain properties on objects. These are important and it's great to practice as much as possible accessing nested properties on objects and sort of iterating through the keys and doing all those operations. So in this case, for Leet Translator, we essentially want to map one value to another. So whenever we want to represent one value as a different value, then an object is the perfect tool to use. And so basically, it looks like we just want to go through and for each character in this string that we have input as an input, we want to map that over to the appropriate code. And so basically, I'd imagine an object to look like, with every single character to have its corresponding Leet character. And then for B, we'd have 8 and so on. So first, what I'd want to do is just go through the letters array and then for each, so actually first I want to create my object, create map object, and then go through the letters array and use each letter as the key. So essentially for objects, a lot of times we want to determine whether it's useful to store something as the key or as the value. In this case, because this output string, because it's composed of Leet characters, we probably want the value to be the Leet character because that's what we want to output. And so we'll use each letter as the key, and then for each letter, we will store the corresponding Leet character as the value. So yeah, and that's basically our map that we're creating, our lookup. And then when we finally have that object, we can just iterate through the string, the input, and look up each character in our map object. And then we'll just basically, when we find a character, we'll just add it to an aggregate. So I guess we can have like 1A and have this initialize a translated string at an empty string, and then we're just going to add to it as we iterate through the input string. So in this case, we'll just take these instructions and translate them over directly. So we have our function, and it takes in an input string, and we'll use these global parameters because they're in the outer scope. We have access to them in our function, so we can just say this will be our letter index 0, and then letter index dot length, or letters dot length letter index is less than letters dot length letter index plus plus. So here we'll have our letter equals letters at the letter index. So we'll have our letter here, so that'll be A, for example. And now we created our object letter to lead map, and we'll just initialize it as empty object, and then here we'll just say letter to lead map, and then we'll use the square bracket notation because this is a variable, so we need to use square bracket. If we used dot notation and we did this, then that would mean we're creating a property called letter. So it would be a string called letter. So we need to use our square bracket in this case, and then we would set that to be lead chars at letter index. If we assume that they're all one-to-one, which I believe they should be. So that's our object. When we're done iterating through, we're basically saying, letters A and then lead characters A. So then our object will be like A for our first iteration, and then it'll continue on and build up the entire library that we need. And let me just create our string. So lead string is going to be an empty string, and then we'll just iterate through our input string. And our character will be input string at I. So when we have our character, how would we get our corresponding lead character? Now that we have our object that looks like this, so in order to get our lead character, we would probably need to access that property. So we have lead string plus equals to letter to lead map, and then have it use our character to access, and then that should be sufficient. I think we need to do 2 lowercase and return that lead string. Cool. Are there any questions about this problem? If not, then we'll go on to the next problem, which is, dang, sorry, Katie. I closed it out, but let me open it back up. So basically I looped twice because the first loop was through this array in order for me to build up that object. So I needed to build up my lookup object. So my lookup, it was going to need to look like A would be mapped to A, and B would be mapped to 8, and C would be mapped to open. Okay, so how we match the two up is basically we have our lookup here, and now when we go through our input, so let's say here it says full stack, right? So when we get our input element of full stack, then basically for F, yeah, you don't, so Raymond asks it that you don't have to create a lookup object. You don't have to create one. You can just say, there's probably a different way to solve it as well, but I think this makes use of objects pretty well. So I just decided to use a lookup object. But basically, to answer Katie's question about matching the two up, basically we go through each character in this string, and then we try to find that character as a key of this lookup. And then once we find the key, we have the value. And the value is what we want, because we want to basically turn all of these into the lead character. So we're just doing a lookup within this object that we created in order to replace. It's kind of like, if we each had a nickname or something. So if there was, if we each had a name and then we try to figure out what our nickname was, then that would be kind of the same thing here, where we have someone like David, and let's say we just called him Dave or something, and that's his nickname. Then, and let's say we had an array of students, so we had David, and then we had Katie, and then or Catherine, and then your nickname was Katie. Then let's say we had all of our names and we wanted to get a list of all of our nicknames. Then we would just go through this list and then try and look up David, and then figure out that David's nickname is Dave. And then look up Catherine and figure out that Catherine's nickname is Katie. So this would be like nicknames. But it's the same idea. I'm just creating an object, and then going into that object, which is kind of like my directory of information that I'm interested in. And I have one piece of the information, but I don't have the other piece. So I need to get that other piece of information by looking into this object. And so that was what I was kind of creating, was like A would be, the value of A is this, and the value of B is 8. So yeah, it's essentially sort of an alias for the key. The value could be thought of as like an alias or just some corresponding data. Yeah, Raymond. So Raymond's solution was using result string and then going through the list, getting it. Yeah, you can use index of letters, index of character, lead characters. Yeah, you can do that. Raymond's solution just doesn't use an object. You don't have to use an object. But given that we're going over objects, I figured I'd use one. But you could have solved it without using it. So does looping once, Winston asks, does looping once just through letters work? We're using I for both letters I, since both are the same way. Yeah. It does work. You only have to loop through letters once. You don't have to loop through both. You're just looping through the letters, and then you're getting that index, and then you're just looking up in lead characters. So yeah, you don't have to loop more than once. You can just do once. One thing I want to point out about Raymond, your solution, is that in terms of performance, though, it's actually going to be a little bit slower, just because index of searches through an entire array. So I'm not sure if Stanley went over this, but it's just something that's good to know. You don't have to stress out over it now, but just knowing that for lookups, it's a lot faster to have an look up a value in an object. So let's say we had our map, or here we have a and B8. So when you do letters.index of, you're basically searching through the entire array for an element. So let's say you're looking for Z, right, in this array. Then you have to go through, from the start, you have to go through 1, 2, and then you have to go all the way through the length of the entire array to find Z or Q or any element in this array. You have to search through potentially all the elements. So that takes a really long time to figure out, oh, is something in this array? It takes a really long time. Whereas for an object, if I want to figure out, oh, what's at A? What's the value at the property of A? That's instantaneous, because basically how you would look is you would just do something like nicknames A or nicknames dot A. And basically you're giving basically you're searching at an address. So you're going directly to this value, and then you're searching for, or directly to this property and getting its value. So that's like instantaneous. So you don't have to iterate through all the elements to find something. So in an array that's really small, like this array is pretty small, there's only 20 something characters, then it's not going to be any different. The speed of the functions are going to be the same. But once this array gets really large, like millions of, let's say you had a Facebook, let's say you had, some crazy famous person, Selena Gomez, like all of her followers that are just hundreds of millions of followers. And let's say among those followers, you're trying to find one guy. You're just trying to find this one person, let's say I follow her and you're trying to find me in that giant list. It would take a really long time, because you need to go to each element in my list and say, oh, like, are you David? No. Are you David? No. And then go to the next guy. Are you David? No. Go to the next guy. Are you David? No. Go to the next guy. Are you David? No. But let's say all of Selena Gomez's followers were in an object, then I could find it instantly. It could be like Selena Gomez followers. And then if all of the keys were by handle, so like, let's say this was my handle and this was my Instagram, and then I could find it really easily, because I would just say Selena Gomez followers dot David, and that's instantaneous. Whereas like if I need to find, if it were kept as a list, if it were kept as an array, it would take way longer, because I would need to go through each element. Like that's basically what index of does under the hood. Like index of searches through the entire array and then tries to find that element. But it's a lot faster to just have this object set up and then just look directly and try to find this property. And then that would be magnitudes, many magnitudes faster. Basically, we have O, if you want to talk in time complexity, it's O of n versus O of 1. So just something to point out the differences of the two, but it was really good that you brought this up, because you can solve problems many different ways. These are all just tools that you should put into your toolbox so that you could figure out what's the best way to solve this or approach this, because you could honestly do it so many different ways, and each of those ways will have a trade-off. but it's good to know those trade-offs. So next one is pet sounds. So a lot of these are just interestingly structured objects and arrays of objects, and we just have to go through and parse them. So it's really common in regular code to see these kinds of data structures. These are probably the most commonly used, at least on the front end, at least on the client. Arrays of objects are just everywhere. That's basically everything. Just because, let's say you had an e-commerce site that, you have, I kind of went over this sometimes earlier, but let's say you just had your clothes. And earlier I used primitive types, so like t-shirt and sweater. But in real life, the string is just not enough to display all the different types of information that realistically we'll need to know about each item. So that's why we represent them as objects, because now we can store so much more data. So we can say, type, we could say category is like t-shirt, and then we could say like ID or SKU number is like blah blah, and then price is like $5, and then like brand is like Nike or something. There's so much more data we can store. So in reality, like almost everything that we see, at least list wise, or almost every single visual element that we see on like a screen is probably at its core an object that has a bunch of properties on it, and we just iterate through the list and just render all of them onto the screen. It's basically really commonly used and as just a representation of data. So that's why we're going through so many of these examples and these nested structures, just because that's a really common way to represent data. And so in this particular problem, we just want to create what these pet sounds are. So let's try and see how we would approach this. First, I'd probably want to figure out, I'd want to go through the array here and find my pet. So like I have a bunch of pets, but I'd probably want to find the one that the first argument, the pet given in the first argument. So I'd probably want to isolate the object that is the value of the pet. So in this case, I'd want to isolate this dog object. So I'd first want to get that, and then what I'd want to do second is access the country and then pull off the value for the country. Country value in the pet object. And then I basically want to concatenate or change this to uppercase, the first character. So change the first character of argument to uppercase, and then mash all the strings together. So, we could do argument 1 plus in plus country plus say plus, and then the country value, something like that, which is basically argument 2. So, argument 1 plus in plus argument 2 plus say, and then country value. So these are all variables. And then in and say are just constant. So we have our function pet sounds, and it takes in a pet name, and it takes in a country. And what's a little confusing here is that we can't really access, it's a nested structure. So we basically need to go through all the elements of this array and figure out for that element, what are the keys? And if the key is actually, if the key matches with the first argument. So first we need to go through the array animal noises. I++. And then we'll say the wrapper object, because it's basically wrapped is going to be animal noises at I. So that's our wrapper object. And we'll say we need to get the keys of this. So we could do something like let pet let's use arg to separate it. So let pet name equals, and then how would I get the pet name from this object? So if I had this object, how would I isolate the pet name, the key? How would I isolate the key from this object? There's a couple of different ways we could do it, but does anybody care to share? arg1, yeah, it is arg1. This pet name arg is the pet name, but that's the parameter that's passed to the function. But how would I? Yeah, perfect. So it's basically object.keys of the wrapper object. So our wrapper object right now is going to look like dog, blah blah. So that's our wrapper object. So in order to get this, I need to compare this to the pet name arg to see if I'm in the right place. So I could do something like let pet name equals object.keys of the wrapper object. So that's going to give me all the keys. So that's basically going to give me dog, because that's the only key that exists, but it'll come in an array form because it potentially could have way more than one key. And then we know that it's the first, we know that there's only going to be one key because there's all of these look consistent. They only have one key. And so this is going to be my pet name. And so now I have my pet name, which is dog. So what do you think comes next? Like if I have a pet name and my pet name arg, what should I do with those two guys? Yeah, Winston, I understand it's pretty confusing. Confuses me too, honestly, but this object has a key of dog. So we need to basically pull this key out somehow in order to make a comparison to see if we're in the right place, if that makes sense. So dog is still in a key and the whole object represented by dog. Essentially, that's just the way this is structured. And sometimes when we create a web app, for example, and we need to get data from an outside source. So let's say we need to get data from Google or get data from let's say there's a weather app and we need to make a request to the weather app to get the weather data. It might look crazy. Like when we get the data back, it might just be like an array with all these like insane nestings. We have no control over how somebody else formats their data. So we might have to take that data and then somehow make it in a like massage it in a way that is easily that we can do something with and display. And so in this case, I could just say, I'm gonna check if I'm in the right place. So I'll say if the pet name, equals pet name arg, then I'm gonna build the string. So my string, my animal noise, is just gonna be an empty string, and then I could just say, I don't even need to. I can do that. I can leave it like that, and then I can say animal noise equals. So what I have now is I have my pet name arg, and so I need to let me see dogs. I need to add an s and a lowercase. I need to uppercase the lowercase. So I could say let final pet name equals pet name or pet name at 0.2 uppercase, because that's the first element of the string, and I'm going to uppercase that. And then I could do plus pet name dot slice 1. So that's basically going to take everything else, and then I need to add an s. So that's my final pet name. And then my final well, actually, I still need to do another layer. Whew, there's a lot of stuff here. So basically, I'm in the right pet name place, but now I need to access the countries. So I'll say let all countries is gonna equal where am I right now? The wrapper object dot at the pet name. So that's going to be all the countries. That's going to be this object right here. And so I need to figure out in there what my proper country is, and I have that country. So I'll say let noise equal all countries at country. So I have my noise now, and I have my final pet name. And I also have my country from the argument. So I think I have everything that I need at this point. So can someone help me build up my final animal noise? So I have, what would be the first argument of this animal noise? I'm going to just use string interpolation. Yeah, it's final pet name. And then, so that's dogs in this case. So it'll be dogs. And then, what would come next? In. And then, what about after this? What would be the proper variable name? Yep, country. Dogs in country. And then after this? Yep, say, and then finally noise. Yep. So here, just don't forget to return the animal noise. I believe we should be good. All right, so it's saying logs native code. Oh, thank you for that. So yeah, it's these kinds of problems are pretty tricky. But one thing that I think helps is to have these structures as you go. So here my wrapper object is dog. So I know that I can access the wrapper object with the pet name to get this like country list. So like USA is something, and you know another country is something else. So I know that because if you kind of use comments or anything to kind of create, and as you go deeper into your nested objects to figure out what these variables represent, then it helps a lot in the long run because you're able to figure out where you are as you go deeper and deeper in. So yeah, are there any questions about this problem? If not, then we'll go on and proceed to dog breeder. So this is all about optional arguments, I believe. So it should return an object that represents a new dog. And this is something that is really commonly done, is you creating an object. So whenever we want to, let's say we're creating a poker game, an online poker game or something. And let's say each card in the poker game is represented by a suit. It's like diamond or something, and a value, which is like king. So let's say our card is represented by this object, then we're going to need to create them 52 times. So if we wanted to create them and make different cards, then we'll probably need a function that can create objects. So this is like a really common use case. So here we have dog breeder, and it'll take in a name and an age. So the simplest case would just be it just returns a name. And I think if you guys haven't run into this already, a cool new feature, well, not new, but a cool feature of JavaScript is that if the name and the value are the same, then we can just omit this and it'll be the same thing as this. If the value and the property have the same name, and we just do something like this, cut out the extra code. So yeah, this should work for certain cases, but it won't work for these defaults. So apparently it's saying that if there's no age, assume it's 0. If there's no name, assume it's Steve. So I could essentially say name equals name or Steve. I could just say age equals age or 0. And then it should never be undefined. I've probably said this a million times, but it is definitely important and also pretty confusing. So again, this is pretty much let age equals age. This is pretty much what's happening when we have our parameters and declare and initialize our parameters like this. This is what's happening under the hood. And so we can just reassign them if we wanted to because they've already been declared. So we're not declaring, we're not redeclaring. We wouldn't be able to do this. But since they're already declared, I believe we can just reassign. And yeah. All right, so it's saying the name 3 to equal Steve. If only the age is defined. You see the spec list. The default name. Is this? Yeah, I'm a little confused why this is not working, but let me just try and do a log to see what's going on here. So I'm going to just console log name age is name. They want age to be name. Name is Sam, name is Steve, age is 15. I feel like I'm matching it up though. I'm not sure. I'll just log since it's a very trusty tool to debug, figure out what these properties are. Name is 3 and age is 0. Name. If only the age is, oh, it's like, oh, I see. It's not, there's no, I see, it's only giving one parameter. Okay, that makes it a little different. Then I can't just do this, sadly. Oh man. All right, so I mean, I guess I can do something like name is name. In this case, I can say, you know, like if type of name, if type of name equals number, then I can just return Steve, and age will be name. This is kind of confusing the way I'm doing it right now, but probably shouldn't do it like this. So we probably shouldn't even call this. Well, the fact that this function is written like this is also really confusing. I probably wouldn't write a function that can take parameters like in a different place to be completely different. So yeah, but we'll just go along with it for now. And here, I think that should work now. All right, so to equal 0. All right. Let's see. So if the name is a number, but in this case, try it again. Dot age undefined to equal 0. So oh, I see. Name undefined to equal Steve. All right. If you guys had trouble with this, don't worry, because usually they're not going to be this tricky with the arguments. What would be a nice way to, if there's arguments that have these different parameters, then a clean way might be like having an object, like passing in an object, so like properties, and then have this be like have name equal properties dot name, have age be properties dot age, so that we know exactly like what the structure of the input's going to be is going to be name, and this could be undefined, this could be an empty string, like it doesn't have to exist. An age could be 0, or it could be undefined, or it could just, it doesn't have to exist even on this object, so that here it would basically be undefined. But usually it's a little more clear to have arguments passed in as an object, because we know exactly what corresponds to what, as opposed to just having this kind of willy-nilly like this. But yeah, it's good practice to figure out how to handle edge cases and such. But yeah, this one's a little trickier than I initially thought. There's a lot of just defaults and different numbers of arguments in different places. But yeah, are there any questions about this problem? If not, then we'll go on to the final one, which is attendance check. Let's keep this up. So this is kind of like the second problem that the previous problem that we went over with all those nested objects and arrays and nested arrays. So it's another good practice. So basically we just have one argument of the day, and we want all the students that are present that day. So we should probably try and make some pseudocode here. So we'll say, create an array of students. So this will be my result array, and it'll just be empty initially. It's my favorite step. It's initializing. And then the second step is going to be, we're essentially going to need to go through all the students and all of the days for those students. So we'll say go through list of students, get the array of days for each student, and then we'll say for each object in the array of days, if the value at the yeah, the value at the key, which is going to be the argument, is true, then push student name into array. So yeah, we'll just go through each student. So in the outer scope, we'll have the name of the student by using probably object.keys of this object to get the property. And then we'll do the same thing kind of. Inside here, we'll get the key. We'll go through all the objects. And then once we find an object that has the key that matches with the argument, then we'll check its value. And if it's true, then we'll pass this name into the array, and we have this, we'll like store this in an intermediate variable. So let's go through this. So we have our attendance check, and it takes in a day. And basically we want to go through every object in this classroom. So I is 0, I is less than day, what is this called? Classroom dot length I plus plus. So here we have our student wrapper. So it'll be equals classroom at I. So this is going to look like Marnie, and then have the array of days. So that's our student wrapper. So we want to get the name of the student. So how do we get the name of the student? If the student wrapper looks like this, an object with a property of the name, how do we get this name? Yeah, student wrapper is this object right here. So how do we get the name from that? Because we do want the name, right? The name, yep, keys. So same way that we did before, student name is going to be object.keys of student wrapper. And then what do we need to do to get the actual name? We're almost there, but we need to do one more step to get the actual name. Any takers? Yeah. So we need to basically access the first index, 0th index, to get the actual name. So we have the student name now. That's important because we actually need to create the array, students array. And so we have that name, and eventually we might later want to push it in. But now we're getting there. So we have our student name, which is, in this case, it's just going to be Marnie. And now we need to access this sub-array of Marnie. So we have the name, which is important because now we can just say days array is going to be, how are we going to get this array? We have our student name, and we have our student wrapper. We probably are going to do another for loop, but right now I just need to access this data structure. So I can't even loop through something unless I have something to loop through first. So I need to get that thing to loop through. So I have this object so far, and I have the name. How would I get this inner nested property? That's a good guess, though. We are going to use another loop. We are going to have to loop one more time. But so object.keys at student name. So student name is Marnie. So it wouldn't be object.keys at student name because student name is a string right now. Maybe I should just do it here. It's more clear. Marnie, and then student wrapper is here. All good guesses, but basically, so my student wrapper is this object, right? My student name is this. So how would I get this? Yeah, exactly. It would just be student wrapper at student name. And we can't use the dot notation because student name is a variable. And so when you do something like dot, then it accesses the literal value, not the symbolic value or the variable value. So we have our days array now. So now our days array is going to look something like Monday. I think yeah. Monday true. Tuesday true. So now we're getting closer. We have our days array. And so now we need to see if we need to do another for loop, and we need to get each of these objects and then check its value. So we'll loop through again all these days. Let j equals 0, j is less than days array dot length j plus plus. So now we have we're looping through our arrays, and then we'll say const day equals day object equals days array at j. So this day object is gonna look like Monday true. So it's gonna look something like that. That's our day object. So how would we tell how are we going to check the value of this given that we have this entire object? How would we see if it's true or false? What variable would we use? Any guesses? We have this object. Yeah, day, exactly. But we kind of I think we need to lowercase the first, oh, actually, no, we don't. Nice. We don't need to do that. It was just my own typing. So we can just say if day object at day, we don't even need to do anything else. We can, because it'll evaluate to truthy or falsy. Then what should we do? So now the day is true. And so what should we do when the day is true? Yeah, exactly. So students dot push, and thankfully we have this variable student name up here. We knew it was going to come in handy. And then here we just return students. So yeah, again, really helpful to be really slow and deliberate when we're working with nested structures to really give them really descriptive names, because it'll help out in the long run. Once you get deeper and deeper and you need to work your way to figure out your bearings, it really helps that these are descriptive names. It also helps that you have these comments that you made to tell you what structure it looks like at each step as you're going. So I would recommend when you're accessing deeply nested structures to use some type of strategy similar to this so that we know what exactly you're looking at and what all the variables mean before it's, as you can see, it's really easy to get lost in the weeds. So Arthur asks, why are we at 0 in line 51? That's because object.keys always returns an array. So if we didn't do this, then it would look like this. And we need to, it's kind of useless to us if it's in an array. So we want to access the first property. Yeah, it's really easy to forget, but object.keys always returns an array. Yeah, are there any other questions? Again, this is really good to practice this kind of thing just because almost everything is represented by an object, and almost every web page is a list or a collection of objects. So basically, almost every data structure that we deal with is just arrays of objects. And objects are just favorable to primitives just because they can hold so much more values. It's hard to represent a item with just a string, but it's much more useful to represent it as an object with a bunch of properties because each item usually is a composite of different properties. So yeah. Why arrays of objects and not objects of objects? That's a great question. That is a really good question. And sometimes they are objects of objects. And sometimes they're not arrays of objects, as you mentioned. But they each have their different use case. So, for example, let's say we cared about order. So let's say we had a web history, or let's say we had a chat or something, right? Even this chat right here, that we're currently using, it would probably be, each message might be, so this whole chat, this Zoom chat that we're in, could be represented as an array of objects. And in this case, we might want to use an array because we care about the order, because we want to see all the messages in the right order. So we have our messages, and this is just an array. And then I'm just going to go from Jessica's. So the user of this message is Jessica. And the content of the message is push. And the timestamp is, some date. Today's date, 3-18, 19? 19 thing. Time is going fast. Okay, so let's say that was one object, and then now we have a couple more in here. Make it look a little nicer so that we can see it better. Now I'm not gonna do everyone's, but the next one is Winston, and your content you said, I skipped over Arthur, and you said add student, and then yeah. So we might want to use an array if we wanted to care about the order, because we're guaranteed that the array will preserve this order. We could have done something like this. Like message 1, and then this, and then message 2, this. But we're not really guaranteed of the order in this case. When we're iterating through these properties, these keys, we're not guaranteed that. So when we do object.keys messages, it should be message 1, message 2, but we're not always guaranteed that that will be the case. Although it actually, if you test it out, it pretty much guarantees the order is pretty much the same, but usually there can be cases where they're not. So we usually try to represent things where we care about the order in an array. And let me think. Yeah, in terms of like filtering, it's a lot easier to use arrays. So if we wanted to, um, get all the messages from Jessica. So let's say there's more Jessica messages. If we wanted all of the Jessica messages, then it would be much weirder. Like in an object, if you're trying to represent that, it would be you would have to like do some type of you would have to kind of translate it to an array anyways. So for filtering and grouping, arrays are also used just so that you can, turn this array into like user specific messages. And then that would just be an array of just Jessica's messages. So like we went from this array to this array, and that happens a lot in web pages where you click filter by, or you go to close and you click men's shoes, and then it like shrinks down your list of things. It's basically taking this big list and then turning it into a smaller list. So yeah, Arthur, you asked arrays order implicitly, and in an object you have to be explicit of the order. Yeah, well, an object, the order is just never guaranteed. Like, objects aren't really there to preserve they don't have a concept of order. Objects are just mainly for lookups. They're for looking something up, like looking up something in a dictionary, or mapping one value to another. It's not the right tool to use if you care about order. So arrays are perfect for preserving order, and it's really flexible in terms of being able to filter like filter on specific criteria, which is like a really common functionality. Is I want to see all of my messages, or I want to see all of I want to filter by month, I want to filter by purchase type in a banking app, for example. So arrays are a great tool for that. Objects are really good, as I mentioned before, for looking things up, because it'll happen instantaneously. So, I mean, the lines between the use cases are somewhat blurred, and I don't think we need to go too deep into all of that yet. But just know that, there's, I guess the two main ideas would be arrays for order. And if you want to check if something exists within a list, then objects are the best. If you want to check if something exists, if you want to see, look up a specific property on an object, that happens really quickly because you're essentially just going to an address, a memory address, as opposed to looking for something in an array where you'll have to go through each item in that array and ask it the specific question of, are you what I'm looking for? Versus just going to an address and then just checking, is it there? And if it's there, then it's there. If it's not, then it's not. So those are probably two main ideas that I would consider. But that was a really good question. And yeah, I guess we can kind of visualize our chat now as just, if we did an X-ray, it would probably just be an object of something that looks like this. All right, so we will get to the lecture now, are there any other questions? So if not, object methods. So this is a short lecture, and it introduces at the end a really confusing concept, but I'll try my best to introduce it in a clear way. But please ask questions if you guys have questions. So objects can have methods. So methods are actions you can perform on a value. They're basically functions. So countries.indexOf is basically, we could think of countries as basically an object. Arrays are objects in JavaScript. There's just a different type of object. But we could think of indexOf as a function that lives on the countries object. And if that's confusing to people, don't worry about it right now. But basically how that works is, because you might be thinking, okay, countries is an array. Like there's no object on countries. But basically what happens is there's this delegation process. So obviously countries itself doesn't have the method indexOf, but there's this delegation chain where basically if it can't find it in that object, then it'll look in a different object that it delegates to. So it goes up like this structure, this chain. And so that's how it finds indexOf, because indexOf isn't directly on countries, it's on a parent of countries. And so that's how it finds that method. But you don't have to care about that for now. But you guys just might be thinking like, well, what do you mean like countries has an indexOf method? Countries doesn't even look like an object. But through some delegation mechanism, it will find it on an ancestor object. And so yeah, we can make our own methods. So objects can hold any type of value. So we see a lot of objects used to hold strings and numbers, booleans, but it can also hold functions. It can also hold other objects. So if we add a function to the object, then it's basically a method. They're just interchangeable terms. But I guess we can call them methods because they're on an object. So yeah, this is the signature. As you can see, this function, so we give it a property name, and then we just use the anonymous function signature to create it. But I believe you could do it many different ways. I'm not even sure of all the different ways you can do it, but we'll try and go over some. So have something like this. Okay, here we go. So we have that function signature, and then basically what we would do is we would do gracehopper.myMethod. But we could also give it an actual name. And I think this still works. Actually, I think I put it in the wrong place. Still works, you can do that, but that's kind of unnecessary just because you're only really gonna be accessing it by the property name anyway, so it's kind of redundant. But you could also use your arrow functions that I see some of you guys using. It's really just a, whatever you want. And you can have, my method, and then you don't even need to do anything in this case. You can just do something like, my method. Or as I said before, if the property and the value are the same name, you don't even need to do an assignment. So all of these works. Can you pass in arguments? Great question. And yeah, you definitely can. So if this takes an argument and it console logs an argument, then what you just do is you just pass in the argument. So it's finally Thursday. There it is. In line 19, how come I don't need a you mean in this line? Oh, 21. Yeah, because that's a great question because I'm not calling it. I'm just setting it. I don't want to call it because I don't even think this is a valid syntax, but there's a difference between calling a function and just setting a function, setting the name that a function is called by to the property of the object. So we don't need this because we don't want to invoke it just yet. This is when we invoke it right here. So that's why we don't use the invocation because in that case then we would be, we could do something like that. If this function returned a function, so if it returned another function that just took in an argument, and console log double the trouble argument, then we could do something like my method is my method. Then we're just returning the function, so we're essentially assigning this function. We're calling this function when we call my method. And so we could do something like that, and then it would still say it's finally Thursday. If we wanted to invoke it, but then that would just mean we're returning another function. Any other questions about methods? If not, then we'll keep chugging along here. So yeah, there's many different ways that we can place these methods on this object, but this is one of them. And we call it the same way. Let me move this chat here. And yeah, methods on an object. So this point is very important. So basically why would you put a method on a object instead of just having it live by itself? It probably makes sense that it's grouped together with that object because it somehow relates to that object in some way. So, we might have let's say we had, I'm trying to think. Let's say we had like a math application or something, and we had geometry functions, we had trigonometry functions, we had calculus functions, and we kind of wanted to group them by its own group. Or what's better is maybe like a Google dashboard. Let's say you had Google Gmail functions, and you had Google Sheets functions, and you had Google Docs functions, and you had these different services that have methods that logically can be grouped together. Then you probably want to do that for clarity. You don't want to, you'd rather have a lot of binders and put everything in those binders versus just having one giant binder that has all your papers in there. It's kind of like the same idea with objects. You kind of want to wrap things in these nice little boxes of objects, give it a nice name, and now you have a bunch of binders as opposed to one giant binder with everything just thrown in there. So yeah, creating and calling a method, get age. As we alluded to earlier, you could pass parameters. So this one takes in year as a parameter, and then it returns that year minus 1906. So we do something like this, and then we do some math here. So it's probably going to be 112. 112. Yeah. So there's two methods on this object, and they each can be invoked outside of the object. Within the object, we're just declaring it, but we're not invoking it. We're just creating it to be invoked at a later time. So here, much similar to the previous examples, we have this method on Grace Hopper object and takes a name and it logs something. Greet will work, but it's redundant to type out Grace's rank and last name twice in the same object. Rank and last name. Yeah, that's true, because in this case, we can make this more customizable and more extendable to different use cases if we use variables. Because when we hard code something like I am Rear Admiral Hopper, we hard coded that. If we hard code, then we're kind of coding ourselves into a box where we have to create more methods if we want to, for different use cases. But if you use variables, that's why using variables is so nice, because you can just pass in different parameters and your function will dynamically change. And so you always want to make things configurable versus like hard coding them. So, this works, but everything is going to say Rear Admiral Hopper. Whereas if you wanted to be more flexible and use rank, then it wouldn't work as well. So Katie asks, can you explain what hard coding is again? I would be delighted to do that. So if we have something like, let's see, this is a good example of something where you have a weatherman. This weatherman will say, it'll take in the temperature and it'll say, it is currently summer, and let's use string interpolation here. The temperature is temp. So this is good. Do a nice little temperature here, but let me remove this. So this is good, but we hard coded summer. That's basically what it means, is like, you can't really change this. It's static. So what if we wanted something that works in the winter and in the fall and in the spring? This won't work in those seasons because you just hard coded. And usually a lot of times it's easiest to just hard code, like get the thing working for the current use case. But you always want to think in the future, like, what if something changes? What if somebody wants, what if we have this shoe? We're making the shoe, but we're going to make it black. But what if someone wants a white shoe? What if someone wants a brown shoe? What if someone wants a blue shoe? So if we want to make this more reusable, then maybe we make it dynamic and say we have a season, and then we just do something like season. And now it's not hard-coded, it's dynamic. It's basically what that means. So yeah, similar to this. If I have this function, um, it only really it's hard coded to Rear Admiral Hopper. So how can we change this? So methods, you could do something like this. Hi, my name is name. And then I'm just using gracehopper.rank, gracehopper.last, and now it's a variable. It's something where it could work for different ranks and different names. So yeah, it's kind of weird because it almost seems like we're using Grace Hopper before it's declared, but basically what happens is this object gets made and then you would call greet. So at that point, Grace Hopper exists. So yeah, we could do this. This works. So now it'll say, Gabe, hi Gabe, I am Rear Admiral Hopper. But what's even better is using this. And this is something that confuses a lot of people, and it's a confusing concept, but what it all boils down to is this is just an object. It's just referring to an object. And that's at the simplest in the simplest case, it's basically an object. And essentially, if we use this, which is a keyword in JavaScript, then it'll take on the value of whatever the surrounding object is based on how it's called. So when we do gracehopper.greet, inside greet, this is going to be Grace Hopper because that's basically the object that the method is like tacked onto. And when we call the function, we're calling it as a property of Grace Hopper. So this is going to represent Grace Hopper. So it's kind of exactly the same as this previous slide. I went really far back. So here we did gracehopper.rank and gracehopper.last. But using this in this scenario is pretty much the same thing. So we have this.rank, this.last, and it's going to function similar to Grace Hopper because this is just an object. And this, in this case, is the Grace Hopper object. So yeah, it's just another reference to the Grace Hopper object. So if we did get this, then returned object would just be Grace Hopper. And yeah, we could just use it just like Grace Hopper. So there's a question. Is it safe to say whenever you see this, you are dealing with an object? I want to say yes, but there may be an exception because usually there's always, but I would say 99% of the time, yes. This is just referring to an object. It's confusing because you're seeing this and it's so ambiguous. What could it be? 99.9% of the time, it's just an object. Now, what object that actually is changes based on how you call the method and whether or not you're instantiating, whether or not you're using the keyword new. There's a bunch of different, whether or not you're reassigning certain things. Like there's a lot of different, you guys will learn this, but for now, it's just we'll get just a slow introduction to it. Just think of it as an object, and when it's a method, when you're using it as a method within an object, then it represents that object, basically. If that makes sense. I'll go over some examples because I know this can be confusing. So here we're just looking at another example here. Yeah, exactly. So Elizabeth asks, so it represents the object that it's in. In this case, yes, not all the time. There's always going to be exceptions to this, but for now we could just think in that vein, and then you guys will learn more going forward. But for now, we could just think, yes, it's just the object that it represents the object that the method is in. So here we have calc, and there it is. This dot num plus this dot num2. This is basically calc, or we could think of it as being the same as calc. So this works. So I know you guys might be thinking, like, why do we need to use this? Let's just use calc. It's more clear. I agree, it's more clear. What is this meaning? It's pretty ambiguous. We have to know that it's an object and that it's the object that the method is defined in. But using this, calc is almost like hard coding in a way, whereas this is variable. So as I mentioned to you earlier with that little brief snippet on hard coding versus dynamic, this is dynamic. It's super dynamic. It's a variable. Whereas calc, it's a variable, but you've already defined it. So essentially, it's hard coded. So let me give an example of why this would be useful. So here, let's say we had a function introduction, right? And this will say it'll log hello, my name is, and let's just say you did this dot name. Then you could use this function, you could reuse it in multiple objects. So here you just have const Daisy is, her name's Daisy, and introduction is introduction, and then you have a name, John. Let's do some. Where's our chat? So yeah, we have Elizabeth. Names Elizabeth. Introduction is introduction. Right? So because we use this, we could do, it could go anywhere now. It's kind of like a very flexible function where it could go into Elizabeth, it could go into Daisy, doesn't really matter. It should just work for. But if we hard coded this to be like a function that does hello, my name is Daisy.name, we could do this and it's clear. It's not confusing. We're not using this, nonsense like that. And it still works, but it's not reusable because you're hard coding it to Daisy. It's really only going to work for Daisy. It's not going to work for Elizabeth. It's not going to work for George. It's not going to work for Arthur. So the reason why we have this is to afford some flexibility into the language where this can be a shapeshifter. It could take many different forms, but it all boils down to it being an object. So yeah, that's pretty much it for today's lecture. I believe it's a short lecture. Um, Again, there's more to this. There's a lot more to this. We don't want to overwhelm you guys right now with all the different ways that this works in the language. It's pretty involved. Um, but this is a little introduction to it. And JS, it's an object-oriented language, which means that, you know, basically JavaScript is, it's a lot of things. It can be, you can use it in an object oriented way. You can also use it in a functional way. There's different styles that you can use JavaScript in, which is why it's such a flexible language. But at the same time, a lot of people have many opinions on whether or not it's the proper tool for certain things. But yeah, essentially, we have these constructs, these objects, and they represent certain things. They're just abstractions of certain real world items, and they play a key role in a lot of applications. So yeah, are there any other questions before we break off into our groups for the day? Hope I did a decent job in explaining what this is, but it's you're bound to forget and then re-remember and forget and re-remember. And then at least this is what it was like for me. Is initially I was struggling with that concept, but I think it really helped to just figure out it's an object. Like, no matter what context it's in, it's basically going to represent an object. And usually when you have it as a method on an object, it's usually going to refer to that object. So you can kind of reference properties on that object without using the name of that object. All right, I've talked a lot. I'm sure you guys are zoning out. So we'll take a quick breather and reconvene in about 5 minutes I'll put you guys in your breakout rooms, and yeah, at about 9:20 we'll go over some problems, answer any questions you guys have. Yeah. Great questions, guys.